Hi again. Welcome to the next section. All right, so far we have talked about why performance is important. We've talked about how to think about performance using metrics. We've talked about the tools that we use to analyze page loading and identify those metrics and figure out what's slowing down a page. And we've also looked at tools that help us monitor performance over time and track regressions. Next, we can move on to probably the most fun part, and that is how to improve performance by using better practices. In this section, we'll learn about the practices and patterns that actually make our pages load faster, consume less bandwidth, remain resilient for returning visitors, and generally just set ourselves up to avoid bottlenecks before they happen. So I'm going to start with the fundamentals that help all metrics and then move on through practices that improve particular metrics more than others. We can start with some classic performance advice that never gets old. We should be optimizing our web delivery files so that they can travel lighter on their trips over the network. Now, optimizing files will require different techniques depending on the kind of files that you're dealing with. So let's talk about some different kinds of files that we would optimize. All right, so here's one of the classics, optimizing images. One tool that I love to use is called Image Optim. It's a desktop app for Mac, and the UI really couldn't be simpler. It's just a window that you drag and drop images onto, and they optimize and overwrite the file wherever it came from. This tool is really great for jobs where you're curating the images manually and don't need to manage huge sets of images like you would on a big e-commerce website or something like that. One downside to Image Optim is it only optimizes JPEGs and PNG files, no other formats than that. So another one that I'd recommend checking out is called Optimage. This one seems to be getting a lot more attention lately. Again, it's an app that you can install on Mac and drag and drop files right over a little window. And I believe the free version limits the number of images that you can optimize per day. But it's pretty cheap to buy a license to the full thing, and I'd encourage doing that. I think it's $15 or so. Optimage supports more formats as well, so formats like WebP. And speaking of WebP, that's a format that you should consider exporting now for performance reasons. It's often a lot lighter than a JPEG or a PNG without a noticeable quality drop. So here's another tool that lets you convert images into WebP, and this one's free. It's called Weaponize, like weaponize, I guess. So you can check that one out at weaponize.org. Browser support for WebP has gotten pretty good, especially in the last year or so, with even Safari support coming up. So as long as you're not too concerned about Internet Explorer, you can freely serve WebP, but I'd still recommend considering negotiating how you serve WebP, so there's a fallback format for browsers that need it. Similarly, in new formats is the AVIF format, which has a little less browser support, but it's coming along as well and often generates the smallest file size amongst any format. So that's definitely one to check out, and I'll explain ways in later parts of this course that you can serve these newer formats in a way that safely will deliver an image to browsers that don't understand them yet. Since I mentioned those formats, I should bring up this great little browser app called Squoosh.app, which lets you export and optimize images for a variety of formats with a really nice UI, and it supports AVIF and WebP. You see that little drag slider, you can compare the quality. It's really very nice, and then download it. And there's even a command line version of it, so you can use it to optimize many files at once. So that's really good to check out. And then there are also more hands-off approaches to optimizing images. Services on the web with APIs that you can pass your image URLs through right from your website, and they'll deliver an appropriate image size on the fly. So you can just drop a reference to their service right into the source attribute of your images, and it'll handle it from there. Cloudinary is one of those, and that's the one I'm showing here. And they essentially become, or they can become, sort of a media management platform for your site. These tools are really good about handling a lot of media. So there's a convenience factor to this sort of setup, and they're really good for working with dynamic content sites like e-commerce, where you have lots and lots of image URLs to manage at a time, and they change very frequently. But services like this also place a dependency on third-party URLs. So you can incur additional network costs and potential for failure if that service happened to go down. So still, it's a really popular and a great approach, but that's something to consider. I should note too that ImageOptim, one of the tools that I showed first, also has a web service like that. And it'll work on Windows as well, if that's what you happen to use, because it's browser-based. So from a website, you can use it through their API and request optimized images on the fly from your image elements URLs. And that's a paid service, while the regular ImageOptim app is free. So a bunch of options there to consider. Next, we'll talk about optimizing video. So with video, there are two formats to care about these days when you're optimizing files. MPEG-4 is one of those formats, and it pretty much works everywhere, but it can create somewhat larger files. And there's WebM, which has really great support as well, but it doesn't work in IE11. WebM tends to be better for compression, so the file size tends to be a little smaller compared to MP4 at a similar quality. So it's really great to offer your users, and I would recommend exporting both if you have the ability. And then you can negotiate which format to serve to the browser depending on which one it supports. Now, I should note that there are a couple of emerging formats to keep an eye on. AV1 is one of those. The browser support is looking pretty good, and compression will be better. Another one is the H.265 video format, which appears to be Safari only at the moment, but is coming along as well. So keep an eye on those. But for easy support for generating videos today, those two formats should do the trick. There are tools that are easy to use for exporting video by hand in these formats. A couple that come to mind for me have graphical UIs, and they're sort of desktop apps, and those are Handbrake and Miro Video Converter. And what's great about these two is you can use them to export not only different file types, but also different sizes of your videos for different screen sizes. And that's really critical with video because it can get quite heavy at larger sizes. We'll get to how to deliver those different formats and sizes of the assets in a little bit. But for now, you can just remember that WebM and MPEG-4 have you covered really well for video. And again, like images, there are both build time tools for video, so you can optimize your files in, say, a node or a gulp kind of build process. And there are also web services, like, again, Cloudinary here, that provide similar URL-based tooling for videos as well as images. Managing images and videos on a big site takes a lot of work to do really well, so these kind of services tend to be worth it. They're really convenient, and the trade-off is in potential delays in processing through a third-party provider. But I think you'll find that it's pretty common to use things like this because managing video is just so complex. Next, let's look at web fonts. For optimizing fonts, we can make sure our files are as small as they can be, just like any other. And with fonts, that process is called subsetting, and it literally means removing characters from the font, letters, numbers, symbols that aren't going to be used on your site. Most fonts contain support for all sorts of languages and character sets that your site may not even use. So you can use tools to subset your fonts to specific character sets. And one of those tools is Font Squirrel, and that's an online tool that you can go to and upload your fonts, select the character sets that you want, and there's really helpful tooling there to give you some sensible defaults for your subsetting, and then download optimized versions of your font files and make them much smaller than the ones that you started with. Another option is a tool called Glyphhanger, which was built by my friend Zach Leatherman. And this one is really neat. You can run the tool against your website. It'll actually crawl the site and figure out what characters you're using and therefore should be supporting in your fonts. So for the ones that you actually need on your site, it'll actually keep those in the font file, and otherwise it'll just remove them. So it's creating a really custom tailored subset font for your site. And once you're subsetted, once you've made your font files small, you'll want to make sure that you're exporting them using modern formats. And font delivery has gotten a lot easier in the last couple of years. The WAF2 format is the most modern format that you're going to export to, and it covers most every browser today except for IE. And that's something that comes up a lot when you talk about support situations. IE tends to be left out, right? So you need a fallback, and WAF1 has good support for IE11. That's just the first version of the WAF file format. And I'll go over once again how to serve those different kinds of files appropriately later when we get into delivery in this section. But generally, WAF2 is just a smaller version of the files that you'd serve with WAF1. So it's a little more optimized and better to serve if you have it. It's worth offering. Another format to consider moving to in the future is called variable fonts. And what's neat about these is that you can deliver one font that covers multiple weights and italics and different styles in a single font file that the browser only has to load once. So overall, it'll be lighter than, say, downloading several weights, especially if you were planning to use several weights on your site anyhow. So variable fonts can be packaged as a WAF2, just like any other font file, and you get multiple versions of a font in one file. And it tends to be smaller than downloading all 3 or 4 or however many versions you happen to be loading. And of course, like other optimizations that we can make to our files, you can use services to optimize your fonts as well. Many font foundries offer their fonts as a service on the web, so you can just reference them as a third party on their servers instead of your own. That, of course, always comes with the downside of having to make a third party request and initiate that whole process of establishing a connection on a new server that you weren't already connected to. And that's a performance implication. It'll add a little delay. But there's a convenience factor as well. And sometimes there's a licensing factor in whether or not you have a choice in hosting font files from particular designers on your own site or not. Sometimes it's just cost prohibitive to do that. So there are services that you can consider. Google Fonts is one of those services. It's really popular. It's well built and it's free. And the benefit, of course, is convenience because the service handles all the optimizations for you, even subsetting to character sets, requesting certain weights. You can do all this just by passing a certain font URL to Google that specifies the configuration that you want. But once again, I would recommend, if you can, to host your font files on your own server. And in the case of Google Fonts, you can actually download the fonts that you want to work with, so you can self-host them. And I'd recommend doing that if you ever have the choice, because it's going to perform much better to have things on the same domain. It's really helpful to make sure that we're not delivering more text in our text files than we actually need. For text files, one of the easiest and most impactful optimizations you can make is to minify the text. Minifying often means removing unnecessary whitespace characters. And some languages make that harder than others. In HTML, of course, whitespace tends to matter a lot, especially when it's interlaced within content, spaces between words and things like that. We don't want that removed. So HTML minifiers are very smart and very conservative about the whitespace that they remove. But there is plenty of whitespace that can be removed in HTML, such as the indentation before tags and around them, things like that. So we have tools that can do that. In the case of CSS text, you might delete lots of new lines and spaces and tabs, all of which add up to font weight. So minifying files helps a lot. And there are online tools that you can use if you just want to quickly optimize the contents of one file and minify the output. This is one of those. I believe it's cssminifier.com, and you can just drag and drop the contents, paste the contents of a file into the left column, and you get the minified output on the right. And that's really handy if you're just making a small site and you just need to run this one time. Don't need to set up a build process for this. But generally, that's going to be pretty tedious if you're editing CSS files a lot. So this is not a solution for a long-term maintenance situation of a site. But there are lots of tools that help you minify your CSS as you develop your site. One of them that I like to use is called CSS Min, and it's a build tool that runs on Node.js, and you can find it on NPM. I can have it minifying my CSS anytime I save a file or I push to production, and it'll just remove the white space and optimize it for delivery. For SVG, the standard tool for optimizing SVG text is called SVGO. SVG is really complicated, and there's so many things you could remove from a file that you don't need if you're not using it. So SVGO gives you lots of options and really good defaults for how to remove and clean up SVGs before serving them over the network. And once again, SVGO has lots of build tools that are built on top of it that you can run during your build process. There are also web-based tools that you can use if you just want to drag and drop or paste a SVG file and optimize it real quick and save the result. So once again, a tool like this, which is called SVG OMG by Jake Archibald, is a really great tool. You can actually see the visual degradation of the file as you optimize it, which is really important with any kind of image file, right? You want to make sure you don't over-optimize the size or quality of a file because it can drop significantly. So this tool is really handy for that, but the downside is it's quite manual, so it's not great for a big build process of icons. So you have the option to do this for case-by-case kind of optimizations. For JavaScript, there are again a lot of options for minifying text. JavaScript is really interesting because unlike the other text languages that I've talked about so far, JavaScript is dynamic, so you can actually go far beyond just removing white space to actually rewriting the contents of the JavaScript to actually change the names of variables if you wanted to use less text overall. Tools like Uglify.js are really popular for minifying JavaScript, and I like to use that one myself. There are tools built into all of the common build packaging tools out there, like Webpack or Grunt or Gulp. So you can check out all the various options and see if there's one that strikes your fancy. We can also run tools that try to remove code that's not being used on our site. One of those tools is called uncss, and it attempts to do this by crawling a site and removing CSS rules that are never referenced in the HTML. And this is particularly good with sites that use frameworks because they tend to be a little heavier than you need and include modules of CSS that you may not even be using. So this tool can go in after the fact and remove that stuff. And that tool has an online version as well. If you just wanted to try it out, you can paste some HTML in on the left column, paste some CSS in on the right, and then uncss it. It'll compare the CSS to the HTML and see if any parts of the CSS are not in use, and you'll get a new file. Again, this is sort of a manual take on it. I would recommend doing something like this in a build process instead, but the option is there to test it out in the browser. For JavaScript, removing code that's not being used is a lot more complicated, and that's again because JavaScript is dynamic, and unlike CSS, it's hard to tell what's in use if you were to, say, run static analysis against a particular portion of JavaScript that's being delivered to the browser. But it is possible when you use these frameworks to analyze the script dynamically and see if there's any code that's being included that's not being used. That process tends to be called tree shaking, and a lot of developer tools today, such as Webpack, are very good at that process. They'll look over your code base and they'll try to find code that was imported or loaded but never used, and it'll remove that to make a tighter compressed output that you can deliver on the web. And lastly, and then we get to actually compressing the files that we want to transfer when they're carried over the network. And that's different than just changing the contents of the file. We're actually performing a inflate or deflate kind of process, like if you were to zip a file on your computer locally. It's the same thing. And browsers are built to accept files that are zipped or compressed as they are sent to the browser, and the browser knows how to unpack them when they arrive. So you'll want to compress any text files anytime they're sent over the network. And the main algorithm that we use for compression over the network is called deflate. And browsers support deflate very broadly. gzip is the most common use of the deflate algorithm that you would hear about on the web today. And gzip runs fast enough that it can compress files as they're requested on the fly on a web server. It's very quick. It'll just turn around a file real quick that's gzipped. And here's an example in Apache's server syntax that does that for any HTML, SVG, JavaScript, or CSS file. It just, if it gets a request for a particular kind of file, it sets a filter on it to deflate, and it crunches that file down. It's ready for transport before it sends it to the browser. Deflate works really well by compressing redundant text, so it really excels at the sort of languages that we use on the web that repeat themselves a lot, like CSS and HTML, for example. And again, when a compressed file arrives in the browser will inflate the file back to its original state again, so it's only small during transit. And that's why we get that situation where JavaScript is unpacked into a much larger size when it arrives on the device. And that eventual size translates to how much memory and everything it consumes after it is evaluated. In DevTools, you can make sure that file compression is working properly by looking at a file in your network panel. And you can see that there should be a difference between the transfer size and the actual size. If you look at the two columns there, transfer size should always be smaller than the actual size when you're dealing with text files. Another algorithm that uses deflate is called Brotli, and it makes smaller files, and we should use it if we can. It makes smaller files generally than gzip can. Here's how to enable it in Apache web server. Once again, it's just another Apache plugin. Depending on the server you use, it would be a different way to enable Brotli, but generally the way Brotli works is very nice. The browser tells the server if it can accept that format of compression, and if it can, the server will give it that. Otherwise, it will give it something like gzip. And browser support, once again, is quite good. Pretty much every browser that we see today except for IE11. So if you were serving Brotli on your server, you would use a module that automatically degrades to serving gzip or something like it to IE11. So there's a nice fallback there. Another one that is up and coming, it's been out a while though actually, is Zopfli or Zopfly. And that's a Google algorithm that uses deflate as well, and it produces an even denser footprint or a smaller file than other tools like it. But the problem with some of these tools, and what's described in this post about Zopefly, is that it's slow, 2 to 3 times slower to compress a file. So they actually recommend that you use this kind of tool for pre-compressing files that are static and ready just to be sent to the browser, but not compressed on the fly every time that they're requested, because then you would incur a server delay. So all of these ways to optimize our files are great for web delivery. In performance, weight definitely matters these days. But as we've described earlier in this lecture series, weight isn't everything. It definitely isn't everything for perceived performance, especially. So I like to say that more weight doesn't have to mean more weight. And this image, this timeline, is a good example of that. It's from an experiment that I did a little while back to demonstrate this concept. We took an article page on the Wired site and optimized the page delivery alone. We never touched the size of the actual files that were being loaded by the site, but we did reprioritize the way that the site was requesting those files. And this was a heavy site. It was 8 or 9 megabytes, I believe. And we were able to cut almost 9 seconds off of that page's time to first rendering content on 3G simply by reprioritizing the delivery. So again, weight matters a lot because, as we know, it impacts loading time in different ways, but it also impacts costs of how much you're downloading on your data plan, things like that. But it isn't everything. So with that, we should move on to perceived performance.